In this video, we are going to be adding an LCD to the Raspberry Pi PBX and getting it to display some useful information about Asterisk and the system. We'll be using the WAVESHARE 2.3-inch OLED HAT that gives you a screen size of about 128 by 32 pixels. The result's a really cool mod for your Raspberry Pi Asterisk-based PBX. If you're interested in seeing how we do this, stick around. Hey guys, my name is Conrad de Vet. Thank you for watching Innovate Asterisk. Please feel free to subscribe to this channel if you have not already, as I will be adding regular videos such as this one on anything Asterisk related. And remember, it's largely based on the Raspberry Pi project. If you have any suggestions and topics you'd like me to cover, please feel free to post them in the section below in the comment section. This video will consist of 6 steps and a bonus step. Step 1 will be installing the Raspbian OS onto our SD card. We'll then be installing the latest version of Asterisk and Samba so that we can access our config files. In step 3, we'll configure Samba and Asterisk so that we can have a test call between 2 extensions. In step 4, we will actually install the LCD and the drivers or the configuration files for it, and we will use Python for that. So in step 5, we will write our Python scripts and test our display. So step 6 will be running our own Python scripts where we connect to Asterisk and display some results. And the bonus step, we will be uploading a small image so that we can display a logo, and we will do a startup animation. If you have not already watched the installing Asterisk video, then click the link in the description, because that will be a much more detailed explanation as to what we need to do next in step 1. So I'm going to go through quickly now how to get Raspbian OS installed onto the Raspberry Pi. So in step 1, we're going to flash essentially the Raspberry OS downloaded from the internet onto our SD card. So I'm going to go up to my screen and I'm going to go to raspberrypi.org. That's this website over here. I'm going to click on the download section over here, and I'm going to go to the Raspbian link over there. And in Raspbian, I'm going to choose Buster Lite. Click the zip file to download. So I've already downloaded this file, so I'm going to skip forward to that. You don't need to watch through that. The file is now downloaded, so I'm going to now use the terminal to get that file onto the SD card. So I'm going to put the zip file there, move that away, move that away. And Buster Lite is now on my desktop. So I'm going to move that to the bin. I'm going to take that file. I think I'm just going to rename it Raspbian busterlite.img. That's the file I'm going to use to put onto the SD card. So I'm going to go ahead now and put the SD card into the laptop. Once I've done that, the SD card will be mounted onto the OS. So I'm going to use my Mac terminal. But if you're on Windows, you must just follow the instructions on the website as to how to do that. Let me just show you. If you go to installation guide and you go to Windows, you will see that they have to use a different program and you can do it slightly differently. So I'll leave that up to you if you're on a Windows machine, but that's the only difference between Mac and Windows. So let's move that out the way. We're back on the terminal now. And in the terminal, we first need to elevate our privileges to a super user. Now that we're in as super user, I'm going to go disk util, and then I'm going to say list to show the disk, and it is mounted as disk 2. So I'm going to unmount it. Disk util unmount disk, and I'm going to say dev disk disk 2 is the correct one. So then I'm going to check my my image file. So I'm going to say file, then I'm going to say users Conrad Vet desktop, and I'm going to say Raspbian light image, and you can see there it is a disk image. So I'm going to say dd, I'm going to use a block size of 1 meg, and I'm going to say input file is users hold on, input file equals users Conrad Vet desktop Raspbian light, and the output file equals dev disk 2. So now that I'm writing that, I'll skip forward. Okay, as you can see, it's now written the bytes to the disk, and we can now move on. The next thing I need to do is write a small file to the root directory of that disk so that we can access it with SSH. So I'm going to type nano volumes, it's boot, that's what it's called. SSH is the file, so I'm going to use nano, it just writes the file, and then I'm going to say, well, exit, and I'm going to say yes, I want to save it, yes, the file's name is that. So I've got now SSH in the path. If I go cd volumes boot, this boot is the file, and I'm now on that directory. I go ls -l. You should see this SSH is the file that's sitting inside there. So I'm going to now exit that, and we're going to now eject the disk. So I need to disk util disk, spell it right, util, I'm going to unmount disk, and that is dev disk 2. Okay, it's unmounted. Now I can take my disk out and put it into a Raspberry Pi. Okay, so here it is. I'm going to put it back into my little, I've got a little case for it. I'm going to plug in my network over there so that it can get a DHCP IP, and I'm going to boot it up for the first time. Right, it'll take a second to boot up, but there it is. And then I'm going to connect to it. Now, if you saw the other video before, you'll know more about this, but essentially the way to connect to this device is by using its Raspberry Pi.local. So let's clear that. So here I'm going to type SSH space pi at Raspberry Pi.local. So I'm going to now connect to it, and it's going to ask me about the fingerprint. I'm going to say yes, thank you. For next time, the password is Raspberry, and enter. So now I'm in to my Raspberry Pi, and I'm going to now install Asterisk and Samba. So in order to do that, first of all, I need to elevate my privileges. So I'm going to use sudo su. Okay, it's now made me a root user, and I'm going to go apt get update. Now the apt update will update all of the locations on IP addresses for all the different downloads that it's going to do, because we're going to download and install a few things now. So that's what it's busy doing now. Right, now that it's done, it doesn't take very long. I'm going to install Asterisk, apt get install Asterisk, and also Samba, right? So there you go. It's reading all the files, and that's what it's going to install. Now this should be Asterisk 16, with the latest version from the Asterisk website. You can find out more, but I'm just going to say yes to that, and it is going to install it. Probably going to just fast forward this until it's finished. Pretty boring to watch. At some point during the installation, Samba is going to ask you this. It's fine to say no. Right, so you should see something like that once it's done. Both Asterisk and Samba are installed. First of all, we're going to set up Samba. Now, I'm just going to show you that in the top, the installation is as follows. We should see Asterisk. So there's Asterisk installed. And there you will see SMBD, that Samba, is also installed. So these are the two applications that are installed on our box. Q to quit that. Now I'm going to make sure that my Pi username and password is synchronized with Samba. In order to do that, I'm going to say SMB pass. Okay, I'm just going to use tab, just help me out. Pass WD, and then I'm going to say add Pi. That's the Pi username, and it's going to say I'm going to give it the same password, Raspberry, and it's going to ask me to confirm Raspberry. Now that means that the Pi username that we log into this box on is going to be the same as the Samba username and password. It essentially will synchronize it from then on if you do change it, but that's important to note now. Now, next thing is to set up a share for ourselves. So I'm going to say nano etc, and I'm going to say Samba, and then samba.conf. That's really the only thing that's in there. And inside here, I'm going to go down. Look, you can fiddle around with a lot of these settings if you really like, and read through them. There are extensive settings, but I'm really not going to worry too much about it. I just want to make my own share. So you see here, I can comment out printers and things like that. Obviously, there's no printers and stuff like that. I'm going to make myself a share over here. Now, it's easy enough to just type it out, but I have it ready. So I'm going to pop that in over there to save a bit of time. Read through those and copy them off the video and put them into your own Samba if you like. But essentially, that's all I'm going to do. I'm going to save it, yes. Then I'm going to say service SMBD restart. Once the SMBD service is restarted, we can now go back to our computer and in the Finder, choose Go, Connect to Server, because that's where we want to connect to. I already have it here, but essentially you can just type smb:/raspberrypi.local, add it using the add button over there. It's already added for me. I'm then going to go to Connect, and it's going to prompt me for my username and password. Remember, we're using the username Pi and the password Raspberry. It's then going to offer you the share Innovate Asterisk, and we go OK to that. So once connected, you'll see your folders and files over here, and we're interested in going to the etc folder, going to Asterisk, and inside there we have all these files. Now, in order for us to do the test calls that we want to do, I have to actually delete most of this, because otherwise there's just too many config files to consider. So I'm going to go here, I'm going to delete all the files except the files, the config files that I really want. To do that, let me select everything, Apple A, and then I'm going to exclude with the option key the asterisk.conf, cdr.conf. I really want to switch that off really. Might as well use CLI, the codecs, useful. Then I need extconfig, That's very important. Extensions.conf we're going to use, not any of the other one. Modules. Let's go to modules. Where's modules? Modules over there. Music on hold. Yeah, we'll do some music on hold. RDP is fine. And we're going to now do these tests on sip.conf, voicemail.conf, and then I'm going to delete these items. Are you sure you want to delete them? Yes, I'm going to delete them. So it's deleting those files, and I'll be left with just a selection of files. And then Studio Code is a more pleasant editing environment, so that's why I'm using it. I'm going to go open folder, go to Raspberry Pi, Innovate Asterisk, etc. Asterisk. Right, that's the folder we want over there, and you'll see now it displays everything that we want. We can take the release notes out and the welcome message. All right, so we've got asterisk.conf, which has got a lot of stuff. Don't worry about what's inside there for now. CDRs, I'm going to clear out some of that. The only thing I really want to do is say enabled is no. We don't need to log any CDRs for the moment. So let's take that out and all of that, right? So enabled no. S to save. CLI, yep, that's fine. Default codecs, that's fine. ext.conf. So here we're not really going to make any changes, but what we are going to do is, just for our own sake, we're going to say that's actually all that we want. We might come back to this at a later stage, but for now let's leave it like that. That's settings, and those are the settings that we want. And then extensions.conf, I'm going to take the whole lot out, right? I'm going to leave it there. Modules, autoload is yes, so that's fine. It's excluding some of the modules which we don't need. Music on hold again is fine. You should see that our mode is files and our directory is MOH. So on this computer, the music on hold files are there, and that is the default class, which is also what we're going to test in a minute. RTP is fine, so we're going to leave that one. sip.conf, we're going to take the whole lot off there and save that. Voicemail is fine as it is over there. We're not actually going to be using voicemail right now, but it might complain if we don't have it. So sip.conf and extensions.conf, those are the two important files. So I'm removing all the settings from extensions.conf and sip.conf. Now I'm going to put back some of those settings. I have my basic dial plan ready, so I'm just going to copy it down, and that's all it really is. So in the general section, we're saying static yes, write protect no, and clear global virus no. You really need a lot of these settings, but you do have to have a general section. So let's leave that the way that is. And then I've created two contexts over here: play music on hold and from my phones. Now this was used in an earlier video, so that's why I'm using it. If you watch the video called installing Asterisk on a Raspberry Pi, then you will see the usage of this. It has a DID assigned to this extension called 100 and this extension called 200. So user 2 and user 1. Where is user 1 and user 2? Well, there you go. Let's add them to sip.conf. This is now the sip.conf file. So under general, I've got my bind address, which is basically any IP address using port 5060. I've got a context from outside. I haven't described the context from outside over here, but essentially that's what we could do in later videos. I've got some settings which are, they all have a default, but essentially the music on hold suggest is default. That was from the music on hold config file over there. Allow guest is no, always reject is yes, allow subscribe yes, notify hold yes. So these are some settings which I like to put in the top of my sip.conf file, and there is user 1. So as I said, in extensions .conf, the sip user 1 and the user 2. So these are these two guys with a password 123. So as I said in the previous video, user 1 at this IP address will be that one over there, and user 2 will be this one over here. So the last thing to check is what our actual IP address is. So I'm going to go ifconfig, double check. Did we get the same IP address? Yes, we got the same IP address over there. So these things, this comment is correct, and our extension should register. So in order to do that and to load these configurations into Asterisk, I need to restart it. Service Asterisk. Oops. Restart. Okay, it's restarted. Now I can access the CLI by going asterisk space dash R, and there I can see SIP show peers, my two users. Now I'm going to launch Zoiper. And under Zoiper, you should see that I have now registered my extension. So if I do that, SIP show peers, it's now registered. Go back to Zoiper. If you want to know how I registered this extension, please watch the video on installing Asterisk. But essentially, I can go to the configuration, accounts, user 1, add my details over there, and that's the details over there. I do have two, but I'm only interested in this one because that's for this demonstration purposes. And I can type any number, remembering that my dial plan was set that if I dial 100, it goes to user 1. If I dial 200, it goes to user 2. And if I dial any other, it plays music on hold. So I'm going to do 1, 2, 3, for example, and test. I get music on hold. Great. So that's exactly what our dial plan said was going to happen, and that's what's happening here. The reason why we're doing this is so that we can read the channel numbers out of the Asterisk CLI. So here we can go call show channels. You can see there I've got 0. But if I do that and go 1, 2, 3, enter, I go back to my call show channels, and I can see that I've got one active channel for one active call. Right? So that's exactly what we want to display on our LCD. The other thing to remember is that for every call, 2 channels are active unless you're dialing to the Asterisk PBX, right? So I just want to make sure you understand that. A call will be made out of 2 channels. That's the leg of the call from the extension to Asterisk. Let's just pause that for a second. That's the leg of the call from the extension to Asterisk, and then the leg of the call from the PBX to the other extension. Meaning that if 2 extensions phone each other, then you will have 1 call but 2 active channels. So I'm now going to open up Zoiper on my phone. Okay, using the same sort of configuration on Zoiper on my phone, I'm then going to register this extension onto that phone. Alright, so there you can see I've got my test user registered. There it says, where is it? There. Ready? Okay, and if I go back to my screen, I can say SIP show peers, and there I have 2 users, right? 100 user 1 and user 2, and we know their DIDs as 100 and 200. Now this is user 2 on Zoiper, so in other words, if I wanted to dial him, I can phone 100, and there's my incoming call, right? I can accept that call, and creates a bit of an echo. Let's mute myself. Right, but here I'm going to go core show channels, and I can see 2 active channels, 1 active core. You can see the actual channels here. SIP user 1 on this channel, and SIP user 2 on this channel. Right. So that's describing the basic way that Asterisk handles calls. Everything is channels, but not everything is calls. So in this case, I've got 2 active channels and 1 active call. Right, I'm going to end that now, and I end that one now, because we need to move on and install the LCD. All right, so let's just recap for a second. We've taken the Raspbian OS and we've installed it onto the SD card. We then inserted our SD card, booted it up, installed Samba for easy access to the file system. We then installed Asterisk, and we changed all the configuration files to a very basic extension to extension calling type layout. Right, now it's time to install the actual LCD. But in order to do that, we need to enable the GPIO circuitry that's on the top of the Raspberry Pi box. That's this line over here. So in order to install the LCD there onto this GPIO part of the circuit board, I need to enable something, and that is the serial peripheral interface. In order to do that, I'm going to go back to my screen. I'm going to exit from Asterisk if you are not already, and then I'm going to type in, so I'm already, you can see I'm already in as root as super user, so I don't have to sudo this command. I'm going to say raspi-conf. I'm just going to tab that to assist me. I'm going to go to interface options. That's this one, number 5. And then I'm going to go to SPI, and I'm say, would you like to enable the SPI interface? And I want to say choose yes. It says then it is enabled, and now I can go down to finish and finish it. So that's an important step to enable the SPI interface. There are 2 ways to work with this LCD. So let me just show it to you quickly. It is the Wave, move that out the way. It is the WAVESHARE LCD. Do a little bit of unboxing for you. That's all there really is to it. There's some mounting screws inside. You get that with it. We're not going to use that. So put that back in the box. Oh, there you go. So that is the LCD. So that is the 2.23 inch OLED LCD. So in order to install that on there, first of all, I need to switch it off. So I'm going to go back to my screen. I'm still on root, and I'm just going to say halt. Right, that closes the connection and shuts down my Raspberry Pi. You'll see that the light is still on, but the green light or the disk activity is not flashing at all. So I'm going to pull out the power. I'm then going to take this, and you'll see, there you go. This is the receiving side of the hat. That's this GPIO over there. I'm going to essentially turn it around, and I'm going to push it on there. But while I've got it this way, I just want to show you something. There it says SPI. Oh, can I use a pen? There it says SPI, right? Can you see that? And that says I2C. Now I2C, which is not really I2, it's more like I squared. Essentially it's integrated circuit, sorry. So I basically squared, II or I2, whatever. But in order to activate that on this LCD, you have to resolder those resistors onto there. And I'm not going to do that. I'm going to use it on the SPI using the hat as a communication medium. Now I'm going to make sure I'm very careful to align the pins correctly, and I'm just going to use a little bit of pressure to push that down onto the board, right? So there you'll see it's now quite nice and tight. Sorry about this, I've got a really silly camera. There you go. It's pushed nice and tight onto that hat. Okay, so there it sits. That's its intended position. If you need to extend this elsewhere, you can either extend the GPIO with an extension cable, although I'm not going to use it in any other configuration. We're going to put it like that, and I'm going to demonstrate what we're going to do with this view over here. So now I'm going to plug it back in, and that will give my board power. Then I'm going to go through some demonstrations with you. Okay, so I'm now back on my terminal, and I have logged in again. In order to continue, I need to install some Python code, because the Python libraries and code have essentially got all the scripts and tools and things that we need in order to complete our project. So it's really quite sort of straightforward, really. The packages that I will need to be installing now is Python pip, which is actually just a way to install another set of programs, PIL and NumPy. So I'm just going to say install. Yes. And SPI dev. Right. So those two things are installed. In fact, the GPIO was already installed, and the SPI dev is now installed as well. We now can use Python to issue commands onto our LCD, well, onto the GPIO, but not specifically the LCD. So the LCD itself requires a set of libraries and tools which are specifically set up for it to operate. So in order to do that, I'm going to go to the website, the manufacturer's website, and download a library. That website is this one over here. It is waveshare.com wiki 2.2 3-inch OLED HAT. Okay, so go to that address over there. I will put that in the video description. And sort of really near the end over here, we want to get this code over here. Now you'll need to copy this link, all right, and you'll need to go over here and you'll need to wget it. So wget, paste, and download. It's going to download a 7Z or a zip file, so I'm just going to let that download. Right, but in order to extract that, I'm going to need to apt. Well, we're not in root, so I'm going to say sudo apt get install, and it's called p7 zip. So let's do that. p7 zip. Yes. Okay, so it's installed, and I can use p7 zip to deflate with the D command, and then at 2.3 is the 7-zip file. Right, so that's given me the Raspberry Pi folder inside my root directory. Now I don't actually need any of the other ones. So now I'm going to essentially delete the other stuff. So I'm going to say rm minus r a Arduino. I don't need that one. I don't need st because that's not this box. And then I'm going to say move the Raspberry Pi. Now the reason why I'm doing this is because I'm trying to rename it to something a bit more friendly for what we're trying to do. So I'm going to say rename it to Raspberry _ Pi. So now I should have a Raspberry _ Pi folder. The space can cause problems for programs like Python, etc. So let's go and have a look what's inside it. So I'm going to say cd Raspberry Pi, yes, and inside here we've got the IIC, that's the I2C, or the SPI. So we want to go cd SPI, and inside here we've got Python, and we've got wiring Pi, and we've got various different libraries and stuff. So I'm going to go to cd Python, all right, and inside here we've got a demo, and that is status.py. So I'm just going to say Python, and I'm going to say status.py. So let me quickly change view to close up, right? Then I'm going to hit enter. Boom, there you go. So my Python is displaying this information onto the screen. At the top, you'll see that I've got the IP address, which, as we know earlier from this video, is 88.85. I've got a CPU load, which is pretty low, 0.09. I've got a memory, and expressed as a percentage. This, of course, is lots of megabytes, which I don't think is very useful. And my disk utilization, 1 of 15 gigs. Right, so that is nice information, great, super, but it's not what we want. So in this project, we want the LCD to display information about Asterisk. So in order to do that, we're going to make our own Asterisk Python file and get information that we want out of it. So now go connect to server, connect back to my Raspberry Pi, choose the Innovate Asterisk. I then have it over there. I can then say, where was it? In Home, Pi, Raspberry Pi, SPI, Python, and that's the file. So let's have a look at what we used. Okay, do you want to install a Python interpreter? Yeah, don't worry about that. It's fine. Close enough. So there's some things in here which have been badly written. And the reason why I say badly written is for the following reasons. So I can put that away. Now I'm going to use Control C over here to exit, right? It's exited. The screen is not actually updating. You saw that earlier on these values were changing quite a bit. So now they're not, right? So I've exited my Python code. The reason is because later on we're going to run this as a service. But in order to do that, you need to essentially be able to go back to essentially here and say USR bin, and then go Python, okay, Python, which will be, by the way, 2.7 by default. So there you go. Quit. Control D, that's what I want. Okay, so the default is Python 2.7. That's in USR bin Python, and we want to be able to execute our code from anywhere. And in order to do that, we went home, we went Pi, we went Raspberry Pi, we went SPI, and we went Python, and we went stats, I think it was, stats, okay, .py. The problem is that this doesn't run when you use it like that. It's failing to import some of the files. So let's go and fix that first of all, and then we can carry on. So back here, it's saying that it's failing to import SPI, but it's got this syspath append situation over here. What it's basically doing is Python is not very good at loading libraries in different locations. And if I can sort of show you, here's my file folder. This drive folder contains all the necessary Python files, compiled Python files as well, that are used to manipulate the GPIO, to work with the SPI, and specifically this device. This is the device over here. That is actually it. All right, but they're in this drive folder, and we're in stats.py. So what do we need to do? Well, we need to do something to this path over here. So in order to fix this, we need to work with sys.path. Now sys.path is actually a list. Right? What it does is it lists all these paths that it should use. So I know, for example, that sys.path 0 is the path to this script file. So I'm going to prepend it there. I'm going to use quotation marks. I prefer to use that. And then I'm going to do that. So in other words, I'm saying here, import sys, then in sys.path, append sys.path 0, the first one, okay, to that list. So we'll have sys.path 0, which is the script file, but then I'm going to append that, then try and import it. So let's save that, right? And let's run that. Okay, so it did something different, and it didn't fail to import SPI, but it failed on this true type font. So let's go and have a look and see what's happening there. Further down, you'll notice that it installs a true type font. Well, it actually reads it at runtime. But essentially, we're going to have the same problem over there. So what we need to do here is we need to add that path again to this file over here. So I'm going to say sys.path, path there, 0 plus / because that was actually only to get to that path, the TTF font file. So I'm going to save that, go back here, I'm going to run that. It's running without error. Let me show you. There you go. It's busy updating. You can see values are changing, so it is live. The other thing that I don't like about this little bit of code is that it uses an extremely fast interval. So, screen. Can you see here, it says here sleep 0.1. Now, 0.1 is basically 1/10 of a second. Well, basically just all the time. So these values are in seconds. Can you see here? It's a delay execution for a given number of seconds, and I'm going to use 1. The reason I'm going to use 1 is because I really don't need it to be refreshing every 1/10 of a second. So I'm going to save that. Okay, and I'm going to go back here, and I'm going to exit that, and I'm going to start it again. Now, I'm going to go back here, and although it only updates every second, right, the one thing that should start seeing is that the load should come down. So it's on 0.5 at the moment, there, 0.4. Okay, it can come down even further, but essentially we're not hitting those scripts so often. So it is every second, which is fine. It's just giving us a reasonable layout. 0.3. Okay, it could come down as much as 0.2. It's essentially not hitting the script so often, so it should be reducing the load. although they're not very complicated scripts, what we are going to be doing in a second, there you go, 0.2. What we are going to be doing in a second is we're going to be accessing Asterisk, right? But in order to access Asterisk every second, right, now we could be putting quite a lot of load on our system. And if we are going to be asking it for the number of calls that are being processed through the system, we're going to be doing it every second. That could be bogging down the system a bit. So, okay, but before we continue, I really want to work on my own file, because this is, it's nice, but it's not what we want to do. So let's go and make our own file and work on that. So I've got here my stats.py, and I'm just going to go File, Save As, and I'm going to choose another name, Asterisk.py. Okay, so I'm going to save that into that directory. It's now Asterisk.py. Okay, and we're going to fiddle that with that in a second. But let's just double check that it's working. So I'm going to go back to my terminal, and I'm going to say, what did I want to do? Not status. I'm going to say Asterisk.py. Okay, let's have a look. Here is the values changing. Now, what do we want to display on our screen? So I'm going to go and make some suggestions here. You, of course, can display anything you like, but I would like to display my logo on the top line. Can you see here? Let's just go through some of these other lines over here. First of all, kind of important, this is the actual LCD display, right? We get 128 by 32 pixels. All right, so you can see here it says 128, 32. All right, that is what we have. That's our display area. Okay, it then does the normal things like initialize, clears, displays. So whenever you do something, you need to issue the display command over there. And then we've got some values like width and height and stuff like that. So those all come from the actual device width and height. Okay. And draw image is what we're going to use to draw, and we can see we set up an image. The basic way this LCD display works is it always takes essentially an image that we construct in memory and places it on the LCD, and we do that in this case every second. So we need to use a true type font. So you'll see here it takes a font and image font, true type syspath, which is what we adjusted, and we make essentially an 8 pixel font. Okay, we know that our pixels are 8 pixels high. So every time we go through our while loop, while true, we execute this batch of code. So that is essentially the display. It updates every second. There's our display. And there's our image. We give it an image each time, right? And then we get a new piece of information on it. And you'll see that we use the sub process, right, of our command. We put through there hostname dash capital I. So let's, good way to test, taking that, going to our terminal and issuing it as a terminal command. Sorry, it's going to need to be made for CLI. So let's take that away. There. Host name, cut, space. Right. So all these commands that I can issue here, you see there, it's issuing that. Now, if I want to display something else on line 1, this is going to be essentially my logo line. This I want to display, yeah, I'll do the IP address, and this and I'll do load, and this I'm going to do asterisk. Okay, so I'm going to get some asterisk information in here. Now you'll see they've mixed up the strings. So the way you do it is you say text, you give it a X and Y tuple over there, and then you give it the string, the font, and the fill. So it takes that many parameters. 1, 2, 3, 4. Okay, but for consistency, I'm going to change it up a little bit than the original script. I'm going to say CPU down here so that it's more consistent. Oops. So I'm going to say CPU over there, IP address over there. So all I really want is the actual IP address over there, and that's what we get in our shell command over there. I also want this to only be CPU. So you see where it says CPU load? Take that out. So in other words, this command will only give me, passed into that, will only give me my CPU load. And then this was memory. And we're not really interested in memory, and we're not interested in disk load. So we've got Innovate Asterisk in our logo line. We've got the IP address in the IP line. We've got the CPU load in the CPU load line, and to do in the next line. So I'm going to go back here to the CLI, and I'm going to run that again. Okay, no errors. Let me show you what that's done. There you go. So I've got my logo line, Innovate Asterisk. I've got my IP address, which is correct. I've got a CPU load, which is very little. And I've got my to-do line over there. Now I want to connect to Asterisk, and I want to find out some information about the number of calls. And in order to do that, we need to access Asterisk on a remote. You remember that -r parameter? So we can issue that into the command line, and we can actually put an X with it as well. What that means is that it doesn't stay inside the remote, which is useful for issuing a command and returning the results. So let's go and have a look how we do that. So I'll need to use sudo asterisk sure. Then I'm going to say core show channels, and I've got no channels, right? So if I were to exit that and say sudo rx and then type the command that I want, core show channels, which is exactly what I issued earlier on, in essentially one line of code, I can output onto the screen exactly that. So let's make a quick call to show you what it's doing. So remember, 1, 2, 3 just plays music on hold. So I've got music on hold playing. So there should be one channel and one active call. Let's go and have a look. There you go. One active channel, one active call. Let's end that. So now, in order to get just that line over there, I'm going to then use some other commands. This one is grep. So we use the pipe sign. So grep. And what's the key or the expression there? Well, let's say active call. Is it calls or call? Well, if it is calls, we can just use call for both. So I'm now grepping active call. So it says there not active calls. Excellent. So it's highlighted and it's actually made it red for us. Just the line which says active calls. But I want just the 0, right? So I'm going to then issue a cut command on that. So I'm going to say cut -d and a space. So essentially the first, after the 0, the space, I want to cut on that one. So I'm going to say d space and the first one. So I'm going to do it like that, and I get 0. Right, so this is the command we're running to get one active call. So let's just double check that that worked. 1, 2, 3, go. I'm in a call, issue my command, 1. Right? Correct. So now we have got our value. I'm going to essentially copy that Oops, a whole lot. Okay, and I'm going to go back here, and I'm going to make a command of it. So let's tab cmd equals quote, paste inside there. So we are using the single quotation marks, so we can leave single quotation marks inside here, right? Because there are double quotation marks on the outside. Okay, so you can see that there's sort of two styles that have happened here. One is this, and one is this. They both work. Right. So I've got sudo *r core show channels, which is what I want. There's actually another command which is a little bit cleaner. I'm going to say core show channels count, which is just the last bit. Grep active core. So this is for calls and not channels. So I'm going to say calls, and then I'm going to copy that one because it's exactly the same as what I want to that. Then I'm going to take that, copy it again, paste it there, and I'm going to say active channel. Remember, we don't know if it's S or not. So active channel, and I'm going to call this chan. So calls are going to be calls, chan's going to be channels. And then I can go here and I can say asterisk. Yes. What do I want to know? I want to say calls channel. Let's go chan. Well, actually, seeing as our LCD, we know exactly what's going on. So str, and I'm going to say it is, what is it called? Calls. Yeah, this one, calls, and then I will put it in brackets, something like that. Chan. So we're gonna see an output saying asterisk call so and so channels something else. str chan, so that's this one. Now I do know that it tends to have special invisible characters and return lines, so I'm going to say strip first, just to be sure. I'm going to strip both of those. Right? So that's what we've got. Let's have a look at what that did. Save. Go back to my, well, I don't need that. Go back up to this command. So nothing is erroring, which is good. And I can say close up here. Right, I have my logo line, innovate asterisk. I have my IP address. I have my CPU load, which is still quite nice and low. You can see it ticking over every second. And I have naught calls and naught channels. So let's make a call. One channel, one call. Excellent. Hang up, naught. Now, let me phone 100 from my cell phone. Right. And here we will see what I was talking about earlier on. So I have one call, two channels. And then I'm going to hang up. Right, so there you go. Our LCD is now displaying information about the logo of sorts, or a little strapline. It's displaying the IP address, and it's displaying the CPU load. Then underneath that, it's displaying a small status about asterisk. is showing the number of calls, and in brackets channels. Remember, the calls and channels are not always the same thing. You take 2 channels typically for a call, but if you are calling in to the actual PBX, then it will just be 1 channel. So now we need to set it up so that it comes on automatically, all right, with the computer, because we don't want to have to issue the Python command every time it starts up. In order to do that, we need to run our Python as a service. So let's take a look at how to do that. I'm going to go here, use Nana, and I'm going to go to my lib systemd system, and I'm going to make up, you'll see here, lcd.service. That is my made up file. Okay, so use the same, do the same, call it asterisk.service or lcd.service, whatever it is. We're going to essentially write a file. And inside there, look, it's got a lot of gumph, but essentially all you really have to do is put this in. So I'm going to pop that in there because I've got it easily. So I've written the description for myself, asterisk lcd service. Okay, it's going to say after conflicts, all these kind of things. Don't worry about what that is. Just write it as you see it over there. Now you'll see what's important is I'm using my execute start, which is user bin Python, which is exactly what we've been using the whole time. Home pi raspberry underscore pi spi python folder, and asterisk.py is the file. So that is the file that we've been running the whole time. So I'm going to Control X to exit, yes to save, and then return. You'll see, there you go, Python asterisk.py. So that's what we put inside this file over there. Right, just before we go ahead with that, the one thing I want to mention is most of these scripts are running on the sudo command, or well, when services sort of run, they run as the root command. It's just sort of how they're built. So the one thing we really want to do is want to make sure that our service, in this case our LCD service, isn't going to be compromised in any way. So we're going to run our service as a local user, as the Pi user, which is what we already have. So we're going to make a quick update to that service file, and then we're going to continue. So I'm back on this file here, and I want to go back to my service file, and I'm going to go inside here. And the one thing I really want to do is I want to set myself up for user and group to be Pi. So let me go here, paste. All right, user Pi, group Pi. Right, so now I can save that, exit that. Now I can issue the command to reload the service. So let me just put that in there. Systemctl daemon reload reloads the service. Then I'm going to enable the service. So I've enabled the service. Right. Now we have our service installed and set up. And now it's just time to restart the Raspberry Pi so we can see the output. There you go. Flashed. And it's displaying 0.33% usage. So that's after a restart. Essentially, it could be a cold start or a restart, same thing. It's going to start the service. So now let's put my screen up. And now you can see I'm going to type 1, 2, 3. Cut back there and call that number. 1 channel, 1 call. Excellent. So anytime we restart this box, the LCD display will come on and stay on indefinitely because of that while loop, while true essentially. Okay, so bonus time. What we're going to do now is we're going to put our own little logo on the LCD. And that is, we're going to make a little graphic in Photoshop or something like that. We're then going to make sure it's in the right format, put it into the folder on the Raspberry Pi, and then we're going to display it for a few seconds on the screen before we go into the normal cycle. Okay, so let's go and have a look how we do that. In order to do this, I'm going to use Photoshop. I'm using the Creative Cloud program, and here I'm going to start by making an image with 128 pixels wide by 32 pixels high. That is the size of this this LCD screen here, 128 by 32 pixels. So that's what you bought, so that's what you're going to display. Now I'm going to go to color is bitmap. Actually, I'm going to do that later. I'm going to go color is RGB, 8-bit is fine, white background. Just remember the background will be whatever you want on your screen. So just remember, black pixels are going to be black on your LCD, or no color, no light, and white is going to be the same as what's on the screen now, which is the white text. There's no shades of gray, there's no nothing, it's only black and white. I'm going to start with a black background. Okay, so I'm going to go there, I'm going to create my screen. So I've got it as RGB color scale, so I'm going to make that a bit bigger for you. Cool, you can all see that. So let's zoom in. And I'm going to display a logo of sorts. So let me start with Innovate Asterisk. All right, so there it is. It's in the middle. Let's align it to the left. Now we can grab that one and go like that. Got a bit of a space over there. Let's put that asterisk sign in there. So let's go and say asterisk. That is what we're going to essentially put on our display. But in order to do that, we need to save this image in the correct format. And the correct format for that is a 1-bit black and white 1-bit bitmap. So I'm going to go to image mode, and I'm going to say, first of all, grayscale, which is, you need to flatten it, and discard the color information, discard yes. So it's one grayscale image. Now I can go to mode and I can say bitmap, yes, 72 pixels per inch, diffuse color, diffusion dither. So what it's going to do is, it's on the soft edges, it's going to use a diffusion dither. And I'm going to say OK to that. It zoomed me out. I'm going to look. Do you think that still looks nice? Let's try one of the other ones. Undo bitmap. Zoom in. Let's do bitmap. Let's do a 50% threshold. In other words, if it was black, it's black. If it's not, that's actually nicer. I think the bar is a bit, at least the asterisk is a little bit funny. So let me go back to under grayscale to where we've got layers again. So I'm going to take that one and I'm going to sort of rotate it a bit. You'll see what the difference between that is. Put that there. Okay, so image mode grayscale, yes. Flatten the image, correct, and discard the color information. Image mode bitmap, 72 pixels. Zoom in again. That is 100%. So innovate asterisk. That's essentially what we're going to display on our screen. So we're going to say file, save as. Just remember, at this point we're going to save it as a bitmap, and I'm going to say logo.bmp. all right, save. Now it's going to ask you what format and what depth. 1-bit, right? So Windows 1-bit is fine. Save. Well, first of all, I need to put that file onto the Raspberry Pi. So I've got my local files here, and I've got my server files here. So very easy. This is the map drive, as you can see down here. and this is my hard drive, as you can see over here. Essentially, I'm just going to take this file and drag it and drop it over there. Can you see it copies over? Nice and easy. Super easy stuff to do, and if you do make any changes later on, you can just keep copying that over and replace it. So I'm here now back in my terminal, and I'm going to first of all go back to my asterisk.py file. So what I want to do, and I'm just going to observe this file a bit more. You'll note that there's a little bit of commenting and stuff like that. That's fine, you can read through that if you like. But this is really the beginning of the initialization. So what it does is it begins, which is the initialize. It then does a clear and a display. Clear and display, basically display is going to output and update the LCD screen. So that's what's actually going to write it onto the screen. So if you clear it and then say write, what it means is there's like a buffer that goes on behind in the memory that takes whatever's on the buffer and then puts it onto the LCD with a display. So most programming systems like this work on the same sort of way. It creates a buffer and then displays the buffer and then goes back to the buffer again. So here's some variables that we're setting up. It's the width and height of the LCD, and that's fine. But this is important. It creates a variable of an image with this image file and creates a new image with a image type 1. So what that is that is the only way for us to put this image onto the system. But when you load an image into Python, it won't necessarily have it in mode 1. So what we want to do is we're just going to reuse this image. Okay? So let's go and have a look what we need to do. So we are going to now make a little area for ourselves. You can see there's some padding and top and bottom and all that kind of stuff. And that's useful. Then there's some fonts setting it up. But this is really where the display loop is started. So this is the display loop. All right, it endlessly displays this information. So before we want to say a splash screen. All right, so this is our splash screen, and inside our splash screen we're going to put a logo. So in order to do a logo, let's declare our variable logo, and then I'm going to make it equal to the image object or image class dot open, and inside open I give it two variables. The one is the path logo dot bmp, right? But in order to do that, I must first go sys dot path. Remember, in order to access this path from anywhere on the computer, we want to use the sys dot path variable, and I'll just make sure it's read only. Okay, so that is the logo. Now I'm then going to take image, which is the image that we declared over there, image, new image. Okay, and I want to basically put this logo onto the image, the existing image that we've already created. And it turns out the easiest way to do that is just to say paste. Okay, image.paste the logo onto the other one. I do need to give it a position, X and Y, because the width and height is exactly the width and height of my LCD screen. Now I tell the LCD screen, that's disp, okay, I tell this LCD screen, that's this one, to display an image, and I give it the normal image as I did before. You'll notice that all of these work on the same thing, image, image, okay, and then as it is below there, tell the LCD disp dot display. Okay, right, so I'm saying load the logo, then I'm saying paste it onto the existing image object, which is in the correct format, and then I'm saying display the image in the buffer and put the buffer out onto the LCD the same way as that. Can you see here I've also got time sleep, so that's exactly what I'm going to do over here. I'm going to say time dot sleep, but this time I'm going to say like 3 seconds. Essentially, I'm just saying display the logo for 3 seconds. Right, let's save that and we'll go back to our CLI and we're going to now run that. So let's go back to our Python script and then I'm going to go close up so I can show you. Oh, here you go. Let me do that while you're watching that. So I'm going to end it and then I'm going to run it again. 1, 2, 3 and carries on. Right, so there you go. We've taken a logo, we've made it a one bit black and white bitmap. We've given it to Python, given it to the system, and we display it for 3 seconds. Now that we have our logo displaying, let's add a little bit of fun. Really all it is, bit of animation. What we're going to do is we're going to have the logo display for 3 seconds and then animate out the way. So in order to do that, I'm going to go and I'm going to adjust my code over here on the splash screen. After that, I want it to animate away. In order to do animation, we're going to start a for loop and we're going to say for, say, x in, I need a range. So I sort of need to say range in a range of 0 to 128. That's the width of the screen. In other words, it must go sort of move off the screen. So from 0 to 128, we're going to keep pasting the logo at a different point. So we're going to say image paste that image, not 0, 0 this time, x and 0. X being the x axis. We're going to move it off the screen. You could do all sorts of things here. You could play around with it however you like. But I'm going to say image display, so image.image and image.display over there. Let's move that up a bit. Okay. And then that is essentially animate off screen. Let's save that. And let's go back to our command line. And I'm going to quickly move over to the LCD. There it is displaying and moving off. Excellent. Let's do that again so that you had a look. So I'm going to hit enter now. So 1, 2, 3 moves away. But now our X is offset. Can you see that little line over there? So the reason we're getting that is because of this X. Can you see that this X over here is the same as this X over here? So it was actually just drawing it all in the same offset over here. So I'm going to call this LX for logo. So I'm going to say logo X is there. Now we're not doubling up on the X variables. I'm going to save that, go back here and run that. And then show you close up, innovate asterisk off, and then displays the screen. Right, there you go. Thank you very much for watching and joining me on this video. I hope you've learned something. That's what this channel is all about. Again, subscribe if you want, like, dislike, comment in the videos, all that kind of stuff, regular things. Thank you very much.